Hello viewers, this is Wagada now taking you through the story of A-level applied mathematics. And this video we're going to go through the solutions for Uneb 2019 of math paper 2. So we shall start with question 1, and question 1 says that the table below shows the masses of bolts bought by a carpenter. So these are the masses in grams, and these are the corresponding number of bolts for each mass. So they said calculate part A, the median mass, and part B, the mean mass of the bolts. So what we shall do, we shall first tabulate our results. We shall begin with the values of x. So the values of x are the same as these values for the mass. So you come here and put those very values there. The next will be the values of f. F means frequency, and to be the very values for these number of bolts here. So you come and put them there. Now this 80 is the total, so when you add all these values, you'll be able to come up with 80, which you put here under the row of total. The next is to multiply f and x. So f and x will multiply this with this. So when I multiply 98 by 8, I'll come up with 784. When I multiply this by this, I'll come up with 1089. When I multiply this by this, I'll come up with 1400. When I multiply this and this, I'll come up with 2020. When I multiply this by this, I'll come up with 1734, and this by this, I'll come up with 618, and this by this I'll come up with 415. So next is to add all these values, and when I add all of them, I'll come up with 8061. And lastly, we need a column of cumulative frequency. So cumulative frequency, you keep on adding the frequency. So first of all, you get this and put it there to come up with 8. Then this 8 plus 11 will get what to put here, which is 19. Then this 19 by plus 14 gives you 33, and this 33 by plus 20 gives you 53, and that 53 by 17 gives you 70, and that 70 plus 6 gives you 76, and that 76 plus 4 gives you 80. So I think we realize that what is here is the same as the last value in the cumulative frequency. So now that you have got that, you can go ahead and answer our questions. First, they ask for the mean. So before you get the median. Now, before you get the median, you have to first get the median position. So the median position is given by the formula half n, where n is the total frequency. So in this case, our n is this sort of frequency, which is 80. That's why you put here 80 divided by 2 to come up with the 40th position. So that means that the median position is the 40th position. So how do they get this 40th position? That position is got from cumulative frequency. So you go and look for a value which is slightly greater than 40 or equal to 40. So if you look at this, 8 is not, 19 is not, 33 is not, but this is greater. So this will be the value which is just greater than 40, because the one before it is 33, which is less than 40. So we have to take this value. Now after getting that value, you'll go and look for the corresponding value of x. So the corresponding value of x is 101. Therefore, you'll come and state that the median is 101. So for ungrouped data with frequency distribution, the corresponding value of x, whose cumulative frequency is just less than the median position, is what will become our median. So that was part A. Now we shall go to part B, where they wanted the mean mass. So mean is given by the formula summation of fx over summation of f. So summation of fx is this, and summation of f is that. So we shall substitute for summation of fx and also summation of f. After that, we shall use the calculator to come up with 100.7625. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for the values of fx, then B1 for the values of CF, cumulative frequency, A1 for the median, M1 for substitution, A1 for output. So the question required location of median and calculating the mean. It was a very popular question, meaning it appears frequently in the previous past papers. However, weakness of candidates is that they did not locate the median. So identifying the median was a challenge to many candidates. So advice to teachers is to use of cumulative frequency when the variables are arranged in ascending order or descending order. So cumulative frequency is used when the values are in ascending or descending order. So that was question 1. Now we shall go to question 2. So question 2 says a uniform rod AB of length 3 meters and mass 8 kilograms is freely hinged to a vertical wall at A. A string BC of length 4 meters attached to B and to a point C on the wall keeps the rod in equilibrium. If C is 5 meters vertically above A, find part A the tension in the string and part B the magnitude of the normal reaction at A. So such questions are easily done by drawing a force diagram. So the first thing we have to interpret the question in form of a diagram. So we have a vertical wall. This is our vertical wall now. So next is to show the uniform rod. So uniform rod AB, that is our uniform rod AB. Then they also talked about the string from point B to point C on the vertical wall, which is that string BC. So because the rod is uniform, the weight will act at the center of gravity, which is the midpoint. So this is point D, which is the midpoint, and the weight is 8g because the mass was 8 kilograms. Then this string is tight, meaning it has tension, so one will be here, another one will be there. So this is for this wall and this is for this rod. Then you have to talk about the reaction at the wall. So reaction is resolved into two components. So one will be the horizontal component, which is capital X, and the vertical component, which is capital Y. So it is easier to split it so that you don't get a lot of unknowns. And it is easier because when you are resolving, it becomes easy. Okay, so those are the forces. Now we shall put the angles. So let this be alpha and this also be alpha, alternating angles. Why? Because these angles will help us to take moments. Then also, if that is theta and that is beta, this will also be beta. So those angles are very vital because you have to take moments and also to resolve. So you have to look for a way of getting those angles. The alpha, the beta, this alpha, this beta, and this theta. So we are told that BC is 4 meters, AB is 3 meters, and C and SC is 5 meters. So we shall come and set them there. That AB is 3 meters, BC is 4 meters, SC is 5 meters, and AD, because the midpoint, it will be a half of this, which will be 1.5. So those lengths will enable us to get the angles. So before we go to the next slide, there's our word marks for this slide. So B1 for the correct force diagram, but remember, force diagrams are drawn using a ruler. Now to get the angles alpha, beta, and theta, you choose any one to start with. So if I start with theta, I'll use that. So I'll say that SC squared is equal to CB squared plus BS squared minus 2 times CB times AB times cos theta. So remember, SC is 5, BC is 4, and AB is 3. Therefore, what does that mean? It means that 5 squared means that this 5 squared will be equal to 4 squared plus 3 squared minus 2 times 4 times 3 times cos theta. So that is how they state cosine rule. So you are coming and say that by cosine rule, 5 squared is equal to 4 squared plus 3 squared minus 2 times 4 times 3 times cos squared. So next is simplify. This side, when I take the whole of this is 25 and this is also 25, so when I take this on this side it becomes 0, that's why there is 0 here. Then this is 24, which is there. That means that our theta is equal to 90 degrees. So when it is 90 degrees, it means that now we have a right angled triangle. When you look at this, it will be right angled, ABC will be right angled at B. So when it is right angled at B, it means that sine alpha is equal to 4 over 5 and sine beta is equal to 3 over 5. Why? Because sine is opposite over adjacent. So when we go back here, when I'm here, for this alpha, it means that the opposite is this, and that BC was 4. Then the hypotenuse, will, remember the right angle is here, so the hypotenuse will be this, which is 5. Therefore, sine alpha will be 4 over 5. But when you go to beta, when I go to this beta, the opposite will be this AB, which is 3. And because it's right angle at this point, it means that the hypotenuse will be a C. Therefore, sine beta will be equal to 3 over 5. So that is where these values are coming from. So they will help us in taking moments. So now we shall go to part A, where we shall take moments about about A. So taking moments about A, we shall get t times 3 equal to 8g times 1.5 sine alpha. So let's see how that moment comes from. So when you're taking moments, you have to take clockwise moments to be equal to anti-clockwise moments. So when I'm taking moments about this point, this force cancels because its line of action passes through the pivot, and also this cancels because this line of action passes through the pivot. But this one has a moment, so we shall say, remember when you're taking moments, we take FD sine theta. So the F is the force, which will be 8g. Then the D is the distance from the pivot to the point where the force meets the rod, and that distance is 1.5. Then the sine theta, now in this case it is sine alpha, which is that. So the moment will be 8g times 1.5 times sine alpha. That will now be a clockwise moment. What about the anti-clockwise moment? Anti-clockwise moment will be got from t. So remember, I still use FD sine theta. So the F is now the tension, then the D is the distance from the pivot to the point where the line of action meets the rod. So that is AB is 3, and the angle in between the force and the rod is theta. Therefore the moment will be t times 3 sine theta, which is t times 3 sine 90. But remember, sine 90 is equal to 1, so in the end we shall come up with t times 3. So that is where this moment is coming from, the t times 3 and also the 8g times 1.5 sine alpha. So I think now, since we know that sine alpha is equal to 4 over 5, we shall come and substitute and remain with only one unknown. So because g is also known as 9.8, it's a constant. For A-level math it is 9.8. Therefore t will be equal to 31.36. So that was part A. Now we shall go to part B. Part B, they wanted the normal reaction, so resolving horizontally, we shall get the component of the reaction perpendicular to the wall, which will be x, and that x will be equal to t sine beta. Now we know the value of t, and we also know the value of sine beta, so we shall come and substitute. Therefore t is there, sine beta is that, so we shall come up with x being equal to 18.816 newtons. So basically that's what they wanted, and now let's see how much can be awarded. M1 for taking moments, A1 for the tension, M1 for substitution, and A1 for the normal reaction. So the question required drawing a first diagram correctly and locating 90 degrees. So this was supposed to be 90 degrees between 3 and 4 lengths, and then taking moments about the hinge. So the question was unpopular, meaning it appears less frequently in the previous past papers. So kindness weakness is identifying 90 degrees between the rod 3 meters and the string length 4 meters. So it's not easy. So if you cannot identify it, is easier to use cosine rule there, just like we did in the question. It will be easier for you to identify it. Advice of teacher is that a triangular dimension of 3, 4, 5 has a right angle between 3 and 4. But if you cannot identify it, then you have to use cosine rule, just as we did in the question. So that was question 2. Now we shall go to question 3. So question 3 says, use trapezium rule with 7 ordinates to estimate this integral correct to 2 significant figures. So first of all, we shall say that our y is equal to this given function which they want you to integrate, and our h will be equal to the difference between the limits, so which is 3 minus 4 over the interval. So the interval is number of ordinates minus 1, so 7 minus 1 gives you the interval, and therefore when I say 3 minus 0 divided by 7 minus 1, I'll come up with 0.5 as my h. So next is to tabulate our results. So trapezium questions on trapezium rule are easily done when you tabulate. So you start with our n, which means the number of ordinates. So those are the number of ordinates: 0, 1, 2, 3, 4, 5, and 6. Now you're ending at 6. This is 7, but you're ending at 6 because we started with 0. So you can either start with 0 or start with 1. So if I start with 1, it means I'll end with 7, which is here. Or if I start with 0, I'll end at 6. So that's the column for the number of ordinates. Next will be the column for the values of x. Now values of x are these limits. So they start from 0 and end at 3, leaving intervals of 0.5, widths of 0.5. So the first one will be 0.0, then add 0.5 to get that, 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 plus 0.5 to get that, and plus 0.5 to get that. So the starting value must be the lower limit, and the end value must be the upper limit. Now next is to get the values of y. Now these values of y are split into two. One column will have the first value and the last value. That's why you see here y0, y0 and y6, because y0 gives you the first value and y6 gives the last value. So how do they get this value? So y0, it means that you substitute this value of x in this part. So when I substitute that there, I'll come up with 0. Why? Because 1.2 to the power 0 is 0 and number to the power 0 is 1. So 1.2 to the power 0 is 1. Now 1 minus 1 gives you 0, so in the end we'll come up with that 0. The next is substitute this value here. So when I substitute there, I'll come up with 0.8532. So remember that we have to use more than 2 decimal places in this column. So they have given us the actual choice of 2. If you use 2 decimal places, that will be very wrong. So you have to use more than 2 decimal places. So I prefer that the given accuracy, you add 2 more decimal places. So if they give you 2, you add 2 to get 4 decimal places. If they want the accuracy to 3 decimal places, you add 2 to get 5 decimal places, like that. So keep on adding 2 more decimal places while working out. Then at the very end, that's when you round off the given number to the required number of decimal places. Now when I add this to this, I'll come up with that. So in this other column we shall put the intermediate values. So from, that is why you see here, from y1 to y5, these are the intermediate values. Note that we are putting commas, not plus. Some students use plus here and that will not be okay. So that means that when x is 0.5, I'll come out, put there x my 0.5 and come up with 0.3089. Then when I put x equal to 1, I'll come up with 0.4472. When I put x equal to 1.5 here, I'll come up with 0.5608. When I put x equal to 2.0 here, I'll come up with 0.6633. And when I put 2.5 there, I'll come up with 0.7599. And when I put 3, no, okay, we stop there because those are the intermediate values. Then next is to add all these values, and when I add all of them, I'll come up with 2.7401. So I've finished generating my table. Next is to substitute in the formula. So that integral will be equal to a half times h. Now our h is this, then multiply by open brackets. So you put this sum of the end values, which is there, plus 2 times the sum of the intermediate value. So that is the formula for trapezium rule, so I have to always remember it. So next is to use the calculator and simplify, but remember after that I'll get 1.58335, but after that I remember that they want accuracy of 2 decimal places, so I'll come and say that the final answer will be 1.58 to 2 decimal places. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for the values of x and B1 for the values of y, so both this and this. Then B1 for the h, value of h, M1 for the substitution, A1 for the output to 2 decimal places. So that means that if you stop here, you'll have missed the last mark of the accuracy. So the question required estimation of area of the given function using trapezium rule with 7 ordinates. So the question was very popular, meaning it appears frequently in the previous past papers. The weakness of candidates is that they failed to determine the value of h. Most candidates forgot to subtract 1 from the number of ordinates. So they just said 3 minus 0 over 7, which is not okay. Then the x values, also they failed to determine the x values and also to state the final value to 2 decimal places. So always remember that the final answer must be to 2 decimal places. So advice to teachers is that the process of finding h and x values must be emphasized. So that was question 3. Now we shall go to question 4. Question 4 says a discrete random variable x has the following probability distribution. So these are the values of x and these are the corresponding probabilities. Find part A the value of p and part B the expected value of x. So such questions are easily done by tabulating. So when you tabulate, you shall come and put the values of x here. Then we shall put the values of px equal to x as they are. Now when we add all these ones, we shall come up with 0.7 plus p. So after getting that, we shall easily get the unknown, because we know that total probability must be equal to 1. Therefore, we shall come and get this one and equate it to 1. Then when I make p the subject, p will be equal to 0.3. So now we shall go to part B, where they want the expected value of x. So that is the mean of x. So there we have to first list down again these probabilities with this unknown substituted. So where there is p, we shall put there 0.3, which we have got here. And when you add all of them, you realize that they add up to 1. The next is to get the column for xpx. So I have to multiply this with this. So this with this gives you 0, this with this gives you 0.17, this with this gives you 0.4, this with this gives you 0.39, this with this gives you 1.2, and this with this gives you 0.45. So after that, I'll add all these values to come up with 2.61. What does that mean? It means that now your expected value of x is 2.61. So basically that's what they wanted. Now let's see how marks can be awarded. So this M1 for addition and equating to 1, A1 for the value of P, M1 for the first and last values of x equal to, so these values, that is M1, and also these values, that is another M1, and A1 for stating. So the question required finding the probability at x equal to 4 and the expected value of x. It was a very popular question, meaning it appears frequently in the previous past papers. However, the weakness of kindness is that they failed to sum and equate the probabilities to 1. And to multiply, they failed to multiply and sum to find the expected value. So the advice to teachers is to emphasize that summation of probabilities is usually equated to 1, because total probability must be equal to 1. So that was question 4. Now we shall go to question 5. So question 5 says, a stone is thrown vertically upwards with a velocity of 16 meters per second from a point h, capital H meters above the ground level. The stone hits the ground 4 seconds later. Calculate part A, the value of h, and part B, the velocity of the stone as it hits the ground. So such question is easily done by first making a sketch. So let's first make a sketch for the given information. So this is the ground level, and this is the starting point at the height of capital H. Then the particles moved vertically upwards, then it comes back and forth to the ground. So the velocity, initial velocity was 16 meters per second, final velocity, let it be v. Then the height, capital H, is the height of the point of projection, then from here to here is the maximum height. So part A, they wanted you to find the value of capital H. So you come and say that for motion ABC from here to through this to C, you realize that displacement is negative h because it is below the point of projection. Initial velocity is u, so this is displacement negative h. Initial velocity is 16. Time taken is 4 seconds. G is 9.8. Time taken is 4 seconds. So what you are going to do, we are going to substitute. So where there is s, we shall put their displacement, which is negative h. U, we shall put there 16. T, we shall put there 4. G, we shall put 9.8, and T, we shall put there 4. So from this, you realize that there is only one unknown. Therefore, when I simplify and make h the subject, it will be 14.4 meters. So before I go to the next slide, let's see how mass can be awarded. So M1 for this, A1 for the output. So that was part A. Now we shall go to part B, where they want the velocity of the stone as it hits the ground. Now before you answer such a question, you have to remember that velocity is a vector quantity. So part B, we shall say that for motion AB, using the third equation of motion, so for motion AB from here, from A up to B, initial velocity is this, but final velocity here is 0, and the displacement is h max. So you come there and substitute for v, U and H and S. So V is final velocity, which is 0, U is initial velocity, which is 16, and G is 9.8, S is H max. So realize that we have only one unknown, therefore we can simplify and make H max the subject to come to be 13.0612. Then for motion BC, still we shall use third equation of motion. Now BC is downwards. So for motion from B to C, now in this case the final velocity is V, which they want, initial velocity is 0, and the displacement is H max plus capital H. Therefore we shall come and substitute for that. So final velocity is what they want, initial velocity is 0, G is 9.8, and S is this H max plus capital H, which is 14.4. Now still here realize that we have only one unknown, so we shall simplify and make V the subject. It will be negative 23.2 meters per second. So when you get square root, it can be plus or minus, but the final answer has to be a negative. So the question is, why is it negative and not positive or plus or minus? It is so because in our calculations, initial velocity was taken to be positive. What does that mean? Remember, initial velocity was going in an upward direction, meaning that if upward velocity is positive, downward velocity must be negative. Hope you know we have realized why we put a negative here. It is because this final velocity is downwards and the initial velocity is upwards, but upward velocity already took the positive sign, meaning downward velocity will take the negative sign. So as long as there's a change in direction, it should be distinguished by a change in sign. So upward is positive, downward will be negative. So always remember that velocity is a vector quantity, therefore you have to show this negative. If they only ask for speed, you would put a positive value. So that's what they wanted. Now let's see how marks can be awarded. So B1 for the value of H max, M1 for the substitution, and A1 for the velocity. And think we see this condition that this velocity must have a sign opposite to that of the initial velocity. So if we had made this one negative, then this would be positive. So always remember that. So the question required calculating the height above the ground level and velocity of the stone while hitting the ground. And the question was popular, meaning it appears frequently in the previous past papers. So Kernel's weaknesses, they failed to identify that the value of H was negative, and also use of the value of G as negative 9.8 meters per second squared. So advice to teachers is to illustrate that when projection is above the ground level, the height is negative, as we saw in the sketch. Then 2 is that to emphasize to students the use of G equal to 9.8 for applied mathematics. So some students, especially those who do physics, they take G to be 9.81, which is not okay. That 1 which you add makes everything different. So for applied mathematics, G is 9.8, and for physics, G is 9.81. And for O level, G is 10. So you have to know the difference based on the level you are on. So that was question 5. Now we shall go to question 6. So question 6 says that the table below shows the commuter bus fares from stage A to stages B, C, D, and E. So these are the stages, these are the distances, and these are the fares. So part A says Jane boarded from A and stopped at a place 2 kilometers after E. How much did she pay? 2 kilometers after E, that means it is extrapolation. Then part B, Okello paid shillings 2,000. How far from A did the bus leave him? So shillings 2,000 should be between C and D, so we have to get that distance from C to D. And that is interpolation. So let's start from part A. So such questions are easily done by first locating where the unknown is. So for part A, it is extrapolation, so we shall come and first tabulate our values. So that point is after E, so they said 2 kilometers after E, so it will be 23 plus 2 to give you this 25. But this figure you don't know it, and it's what we are going to calculate using interpolation. So we'll say change in Y will be this minus this over this minus this to give you this part. Then for the changes in X will be this minus this over this minus that, which gives you this. The next is to make Y the subject, and Y will be equal to shillings 2,650. So that's what they wanted for part A. Now for part B, we also have to tabulate and locate the value of 2,000. So 2,000 is between 1,700 and 2,200. So this one we don't know it, so it's what we are going to look for using interpolation. So here we shall now use change in X, this minus this over this minus this is equal to change in Y, which is this minus this over this minus that, which is that. So next is to make X the subject, and X will be equal to 17.8 kilometers. So basically that's what they wanted. Now let's see how much can be awarded. So this B1 for tabulation is more by many, can be given at that point or at this point. Then M1 for the substitution, A1 for output, M1 for the substitution, A1 for output. So the question required location of unknown by linear extrapolation or interpolation and use of the concept of gradient. It was a very popular question, meaning appears frequently in the previous past papers. The weakness of kindness is the location of the root was done from 0 instead of the immediate value. So you have to get the immediate values, not 0, as we did in the solution. So exam advice to teachers is to relate numerical methods to real life situation problems. So that was question 6. Now we shall go to question 7. So question 7 says the amount of meat sold by a builder is normally distributed. Know this one, normally distributed, meaning now we are dealing with normal distribution, with mean of 43 kilograms and standard deviation of 4 kilograms. Determine the probability that the amount of meat sold is between 40 kilograms and 50 kilograms. So first of all, X will be the random variable, which is for normal distribution. Therefore, the probability between 40 and 50 will be given by X greater than 40 but less than 50. Then from there we have to standardize. So standardizing, we have to use the formula that this value of X minus the mean, which is there, over the standard deviation, which is here. Similarly also this, the value of X minus the mean over the standard deviation, which is there. So that's how they standardize. So next is use the calculator and get this whole value to 3 decimal places and also this to 3 decimal places. Always remember that the Z values must be to 3 decimal places. So when you do that, we shall come up with here to be negative 0.750 and here to be 1.750. And I was thinking to realize that after standardizing, this X becomes Z. Now from this step, it is easier to first make a sketch of the normal curve. So the sketch of the normal curve will be like that. So in between it is 0, then we shall locate this negative 0.750 and that is that. Then also locate the positive 1.750 and that is that. Then after that we shall shade the required probability. So the required probability is from this up to this. So we shall come and shade that. And also shade that. That means that the whole of this shading will be equal to this plus this. So you come and say that from there the next step will be this plus that. The next is to use mathematical tables. So in Uneb they will always be given a table of mathematical formulas and tables, so that is where this extract was got from. So under the normal distribution, under the cumulative normal distribution, so remember you must be keen, there are two tables, one for normal distribution, another one for cumulative normal distribution. So our interest is cumulative normal distribution, so always remember that. So to read the value, I want to read the value of z, where the z is 0.750. So I'll come and say z is here, so these are the values of z, so, and also these are the values of z, so I want 0.75, so 0.7 is here. Then after that I'll look for 5, so 5 I'll get it from here, so I'll come and say from here, these are empty spaces, so that means that you go down and start looking from this, and when I reach 5 I'll get the corresponding, the intersection of this and that. So the corresponding probability is this, because there is no 0 means that you don't add anything on the third decimal point. So the value you want is 2734. So what you should remember, I think we realized that at the very first values they added their 0 point, then they added other values, so it means that all these intermediate values they start with 0 point. So the answer for this probability is 0.2734. Therefore you shall come here and write that is 0.2734. What about for 1.750? So 1.750 still for the same procedure, 1.7, then you look for 5, and that will be 0.4599. That is why you see here 0.4599. So next let's use the calculator to add the 2, and that will give you 0.7333. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for standardization, this standardization, then the Z values must be to 3 decimal places. Then M1 for this addition, then B1 for the table values, this table value, another B1 for this other table value, and A1 for the output. So the question required standardization and reading table values to find probabilities, and it was a very popular question, meaning it appears frequently in the previous past papers. So however, the weakness that candidates fail to read the Z values from the mathematical tables, so you have to use mathematical tables correctly. And like I said, there is normal distribution table and cumulative normal distribution. So for us, our interest is on cumulative normal distribution. Then also use the calculator properly to find the probabilities was also a challenge. So you can use mathematical tables or use calculator. If you use the calculator, the answer with the probability must be to 5 decimal places, and if you use mathematical tables, answer of the probability must be to 4 decimal places. So always remember that. Then advice to teachers is to illustrate the proper use of mathematical tables and calculators to find probabilities of at least 4 decimal places. So that was question 7. Now we shall go to question 8. So question 8 says a particle is moving with simple harmonic motion. When the particle is 15 meters from the equilibrium, its speed is 6 meters per second. When the particle is 13 meters from equilibrium, its speed is 9 meters per second. Find the amplitude of the motion. So first of all, you shall remember that we have realized that what is changing is v and x. So the relationship between v and x is this formula, that v squared is equal to omega squared in brackets r squared minus x. So omega is the angular velocity and r is the amplitude. And in this case, they want the amplitude. So what we are going to do, we are going to substitute that when x is 15, v is 6. Therefore, substitute for v and for x here to remain with an equation with 2 unknowns. Then also, when x is 13, V is 9. Therefore, I'll come and substitute, remain with an equation with two unknowns. Now we have two equations and two unknowns. We have to solve them simultaneously. So when the unknowns are related by a product, the easiest way of solving them is to divide. So what I'm going to do, I'm going to say equation 2 divided by equation 1 gives, so I'll get this equation 2, this is 9 here, and this one is this side, then divide by equation 1, so this 6 is divided by that, and this is divided by that. So with that you realize that this cancels and you remain with that. So 13 squared is 169 and 15 squared is 225, and this over this gives you 2.25. So next is to cross multiply to come up with that, and next is to make R the subject. To make R the subject, I have to bring this one this side and this one the other side to come up with this step. Then R squared is that, therefore R is equal to 23.2422 meters. So that is the amplitude which they wanted. So let's see how much can be awarded. Now this B1 is for equation 1 and B1 for equation 2, M1 for division, M1 for cross multiplying, A1 for the amplitude. So the equation required to formulate two simultaneous equations using V squared is equal to omega squared in brackets R squared minus X squared, and solving for amplitude R. So the equation was not very popular, meaning it appears less frequently in the previous post papers. So the weakness of kindness is formulating the equations from this and solving them simultaneously was a challenge. So I advise to teachers to emphasize application of simple harmonic motion equations. So that was section A. Now we shall go to section B, which has 8 questions, each question carrying 12 marks, and a candidate is expected to answer only 5 questions. But for the sake of revision, we shall answer all the 8 questions. So we shall start with question 9. Question 9 says a car A is 80 meters northwest of point O. Car B is 50 meters north 30 degrees east of O. Car A is moving at 20 meters per second on a straight road towards O, northeastward towards O. Car B is also moving at 10 meters per second on another straight road towards O, northeastward towards O. Determine part A, the initial distance between the two cars, and part B, the velocity of A relative to B, and part C, the shortest distance between the two cars as they approach O. So part A, they wanted the initial distance apart, so that will be, to get the initial distance you have to get the relative position of the two particles of the two cars initially. So RA relative to B is equal to RA minus RB. So what is here is what comes first, followed by this in that order, but they have to be in vector form. So next is to substitute for RA and RB. So where are those values coming from? It depends. You have to first make a simple sketch. For example, they told us that this car A is northwest. Northwest means 45 degrees, so the northwest of O, so northwest is 45 degrees, meaning that even this angle of the horizontal is 45. Therefore, when I will resolve OA, the distance OA is 80 meters, so resolving horizontally to be into the left, which is negative 80 cos 45, and vertically it will be upwards, which is positive 80 sin 45. So that is where this is coming from. For B, they told us car B is north 30 degrees east, so north 30 degrees east is there, meaning the horizontal is 60 degrees. Therefore, when I'm resolving, this is 50 from O to A, therefore from from O to B is 50 meters. Therefore, from moving from O to B, horizontally it is to the right, which is positive, and vertically it is to upwards, which is also positive. So horizontally it will be 50 cos 60 degrees, and vertically it will be 50 sin 60 degrees. So that is where this is coming from. Now next is the calculator and subtract. So this minus this gives me 81.5685, and this minus this gives me 13.2673. But remember they asked for distance. Distance is magnitude, therefore I have to get the magnitude of this, which will be that under square root. So and the outcome will be 82.6404 meters. So basically that's what they wanted in part A. So part B, they wanted the velocity of A relative to B. Now they have to realize that car A is moving 20 meters per second on a straight road towards O. Know that word, towards O. And car B is moving at 10 meters per second on another straight road towards O. So all are moving towards O. Therefore, come and say that velocity of A relative to B is equal to velocity of A minus velocity of B. After that, I'll substitute. So remember they told us that car A is moving at 20 meters per second towards O. So 20 towards O is in this direction. Therefore, horizontal to be to the right, which is positive, but vertical to be downwards, which is negative. That's why you say negative here. Then when I resolve horizontal, it will be, remember magnitude of velocity is 20, therefore horizontal it will be 20 cos 45, and vertical it will be negative 20 sin 45, which is this. For car B, it is moving also towards O. Therefore, moving from towards O, it means you move horizontally, you move to the left, and vertically you move downwards. So both are negative. That's why you see negative here, negative here. But the magnitude of velocity was 10. Therefore, it will be horizontal to be negative 10 cos 45, and vertical to be negative 10 sin 45. 60. So horizontal to be negative 10 cos 60, and vertical to be negative 10 sin 60. That's where this is coming from. So after that we shall subtract. So when I subtract this minus this, I'll come up with 19.1421, and this minus this, I'll come up with negative 5.484819. But remember, velocity is a vector quantity, so you need both magnitude and direction. So we have to get the magnitude and direction, so we have to make a certain sketch. So horizontally it was positive, meaning it is going to the right horizontally, but vertically it was negative, meaning it goes downwards. So where this horizontal component stops, that's where the vertical component starts from. Now that we shall join from start to end, we have to join a line from this to this using a ruler. So when I join, that will be my relative velocity. The direction matters, it has to be from start to end. Then also have to show the right angle triangle and the direction. So this will be our direction. So now that I've made the sketch, the first thing to do is to get the magnitude of velocity, which will be that 19.9116 meters per second. After getting the magnitude, I'll now go and get the direction. So the direction, I have to get this angle first. So I'll use tan, which is opposite over adjacent. Therefore theta will be 74.0194 degrees. In terms of direction, compass direction, it will be south 74.0194 degrees east. So south going towards east. So before we go to the next slide, let's see how much can be awarded for this slide. So here M1 will be for getting this relative position, and this M1 for substituting, and A1 for the magnitude. Then here also M1 for getting this relative velocity in vector form, M1 for substituting, A1 for the magnitude, M1 for getting for this tan theta, and A1 for the direction. So this A1 is not given at this step, it is given at this step when you show the compass directions. Then pass to the one with the shortest distance between the two cars as they approach O. So first of all, we shall get the cross of R relative position and relative velocity. So relative position is this in vector form, relative velocity is this in vector form. So that gives us this magnitude is like getting determinant of a matrix. So you say this times this to give you this, then minus this times this to give you that. And it's a vector quantity which is k component. So when I simplify, I'll come up with that. Therefore, shortest distance will be equal, d minimum will be equal to magnitude of RAB cross VAB over magnitude of VAB. So RAB cross VAB is this, so that its magnitude will be that, and VAB magnitude is that. We already got it in the previous question. So magnitude of this is this, and this is that. Therefore, when I use the calculator, I'll come up with 9.7025 meters. So this is the distance, shortest distance between the two cars. So this is the formula for getting shortest distance between two particles in vector form, relative with relative velocity and relative position. So basically that's what they wanted. Now let's see how mass can be awarded. So M1 for crossing, A1 for output, M1 for division, and A1 for output. So the question required to determine initial distance between two cars A and B, velocity of A relative to B, and shortest distance between the two cars, and it was unpopular. So kindness weakness is the interpretation of the question, and drawing the diagram correctly was a challenge, because this time the direction of the velocities were given indirectly. So advice to teachers is that to emphasize drawing of diagrams, angles and distances, and angles, distances and velocity correctly for resolving to be accurate. So if the angles are not correctly labeled, then resolving will be wrong. So that was question 9. Now we shall go to question 10. So question 10 says that the table below shows the marks obtained in mathematics test by a group of students. So these are the marks, and these are the number of students for each group of marks. So part A, construct a cumulative frequency curve for the data, and part B, use the ogive to find part A, the range between 10th and 70th percentiles. Then Roman 2, probability that a student selected at random scored below 50 marks. So the first thing to do is to tabulate. So we need the column for marks. So the column for marks which I put there are these very values, these ones for marks. Then next is the column for frequency. So the column for frequency, we shall put there the very values for the number of students. Then next the column for CF, or cumulative frequency. So for that one, you keep on adding. So we shall start with this 5 here, put it there. Then this 5 plus this gives you 12. Then this 12 plus this gives you 31. 31 plus this gives you 48. 48 plus this gives you 55. 55 plus this gives you 59. 59 plus this gives you 61. 61 plus this gives you 64. So an ogive is a graph of cumulative frequency against upper class boundaries. So with these cumulative frequencies and these upper class boundaries, shall be able to draw our ogive. So what we need is a graph paper. So let's get a graph paper. And after that we shall draw the axes. And after drawing the axes, we shall choose a suitable demarcate and choose a suitable scale for the horizontal. And then label it as max. Then also choose demarcate for the vertical scale and choose a suitable scale. After which we shall label as cumulative frequency. So next is to plot. Now plotting, like I said, you plot upper class boundaries and cumulative frequency. So for this 15 will correspond to 5, this will correspond to this will correspond to this will correspond to this corresponds to this, and this corresponds to this corresponds to this, and that corresponds to that. So let's plot that and we see. So the first value of 15 is that, second value of 25 is that, then 35 corresponds to that, then 45 corresponds to that, 55 corresponds to that, 65 corresponds to that, 75 corresponds to that, and 85 corresponds to that. So next is to draw a smooth curve, note that word, reasonably smooth curve through all these points. So the curve must pass through the points and it has to be smooth and start and end at the origin. So let's do that. Okay, so basically that's what they wanted in part A. Now we shall go to part B. So for part B, they wanted the range between the 10th and 70th percentile. So the first thing to do is to get the 10th percentile position and 70th percentile position. So let's do that. So for the 10th percentile is P10 position, which will be 10 over 100 multiplied by the total frequency, which is 64, gives you 6.4. So that will be the position for the 10th percentile. What about for the 70th percentile? It will be 70 over 100 times the total frequency, which is 64, and that gives you 44.8. So now that you have got the positions, we shall go and locate them on our ogive. So we shall go to the ogive and locate 64.5 on the vertical. Take a horizontal line to meet the curve. Where it meets the curve, you draw a vertical line downwards to meet the horizontal axis. So that will be the 64th position, and next we have to read this value, and that value will be 17.5. The next was the 44.8 position. So 44.8, draw a horizontal line to meet the curve, then take a vertical line to meet the horizontal line, the horizontal axis, and that will be the 44.8 position. Therefore, next is to read this value, and that value will be 42. So what does that mean? It means that you will come here and say that the range is equal to P70 minus P10, which is 42 minus 17.5, and that gives you 24.5. So now we shall go to Roman 2. So Roman 2, they wanted the probability that a student selected at random scored below 50 marks. So there we shall have to go back to our ogive and look for the 50 marks on the horizontal axis, then draw a vertical line upwards to meet the curve, and then take a horizontal line to meet the vertical axis. So we shall read off this value, and that will be the number of students below 50 marks, that is 52. So now that I've got that, we shall go and get our probability and say that required probability is equal to event over sample space. So F50 over capital N, which is the rate of frequency. When you substitute, F50 will be 52, which I've got in the ogive, and N is 64, which is here. Therefore, the answer will be 0.8125. So you can either leave it like this or you use decimals. So basically, that's what they wanted. Now let's see how marks can be awarded. So B1 for cumulative frequency, this M1 for subtraction here, then B1 for the P70, and this one for P10, and this one is for the output. Then yeah, M1 is for this quotient, and this A1 is for the, so the M1 is for the numerator alone, and A1 for the whole quotient, or this. So any of the two is okay. Then for this ogive, let's see the marks for the ogive. So B1 for plotting all points, B1 for reasonable smooth curve, the curve has to be smooth. M1 attempted to find the 10th percentile, which is this, so these lines have to be seen. Another M1 for attempting to find the 70th percentile, so this has to be seen. M1 for attempting to find the students below 50 marks, so this has to be seen. So the question required to construct an ogive and use it to estimate the 10th and 70th percentile and probability of scoring below 50. The question was very popular, meaning it appears frequently in the previous past papers. So the weakness of candidates is that axes were not labeled, and this is a very big mistake which makes students lose a lot of marks, because when the axes are not labeled, then all the marks will be, all the preceding calculations will be wrong, so it will just be B0. Then 2, using an inappropriate scale that made reading values difficult. So the scale has to be easy to use. Then advice to teachers that demonstrate correct labeling and easy scaling within the required range of values. Don't put what is not in the range of values. So that was question 10. Now we shall go to question 11. So question 11 part A says, show that the equation x minus 3 sine x equal to 0 has a root between 2 and 3. Then part B says, show that the Newton-Raphson iterative formula for estimating the root of the equation in A is given by this expression. Then they say that hence find the root of the equation correct to 2 decimal places. So to show that there is a root, we shall first let this to be equal to fx, which is that. Or that we are going to substitute. Remember, they told us that to show that there is a root between x equal to 2 and x equal to 3. So that means that f2, you substitute 2 here. Therefore, where there is x, you'll be putting there 2. Now, because there is this trigonometric function, it implies that the calculator must be in radians. So when the calculator is in radians and you substitute in this in the calculator, you'll be able to get negative 0.7279. What about f3? F3 means that where there is x, you substitute there 3. The calculator still has to be in radians, so when the calculator is in radians, you'll be able to get 2.5766. Now, since I think we realize that now this is negative and this is positive, therefore we shall come and conclude that since the product of f3 and f2 and f3 is less than 0 means it's negative, then there is a root between 2 and 3. So this conclusion is very necessary. So that was part A. Now we shall go to part B. So part B, they want you to derive Newton-Raphson iterative formula. So for you to derive Newton-Raphson iterative formula, the first thing to do is to get the derivative of fx. So this is fx. Then this derivative will be 1 differentiate x, I'll come up with 1. Differentiate 3 sine x, I'll come up with 3 cos x. So now that we have got fx and f prime x, or derivative of fx, we can come and quote the formula for Newton-Raphson. So the formula is that f is that xn plus 1 is equal to xn minus fxn over f prime xn. So I think realize that now here we put xn and here it is just x. So if you put interchange and put here xn, it will be a wrong expression. And also if you just put here fx, it will also be a wrong expression. So don't confuse the two. Here it is just x and here it is xn. So next we are substitute for fxn and f prime xn. So for fxn, we shall just write this, substitute this very expression, only that instead of writing x, we shall write xn. I think as you can see it there. Then for f prime xn, we shall substitute this very expression, only that where there is x, we shall put there xn. So next is to simplify and get the required expression which is given in the question. So in this case, the first thing to do is to get the LCM. So LCM is this, therefore this is as if it's over 1. Therefore this LCM divide by 1 the same as this, then multiply by this, we'll be able to get xn minus 3xn cos xn. Then after that we shall say this minus is this, then the whole of this will be put here. So xn minus 3 sine xn, but remember it has to be in brackets. After that we shall simplify. So when I simplify, I realize that this xn and this xn cancel, so I remain with this here and this here. So here it is a plus because this negative and this negative gives a positive. Therefore what I'll factorize out 3 because 3 is common here and here, so I'll put it out, which is this. Then I'll begin with a positive expression, so positive sign I'll put it here, and this negative cos xn I'll put it there. So if you look at it, this is the very expression which was given in the question, so that's what we are putting here as required. So before we go to the next slide, let's see how much can be awarded for this slide. So B1 for getting F2 and B1 for getting F3. Remember the calculators should be in radians. Then B1 for conclusion. Then M1 for derivative, M1 for substitution, M1 for combining into one quotient, and B1 for simplifying to the required expression. So they told us that hence find the root of the equation correct to 2 decimal places. Now for the hence part, we shall come and we have to first get x naught, or the initial approximation. So if you look at f3 and f2, you realize that the value of f2 is closer to 0 than the value of f3, meaning that the root is closer to 2. Therefore, as you choose your initial approximation, choose a value which is closer to 2 but not equal to 2. So in this case, let's say let our x naught be equal to 2.2. So if you say x naught equal to 2 or 2.0, that will be a wrong approximation. So always the initial approximation must just be closer to 2 but not equal to the extremes. So when x naught is equal to 2.2, what I'll do, I'll substitute x naught where there is xn, so that I can get fx1. So x1 will be equal to 3 in brackets sine 2.2 minus 2.2 cos 2.2 over everything divided by 1 minus 3 cos 2.2. So here I have to remember that the calculator should be in radians. So when the calculator is in radians, I'll be able to get 2.2815 as my x1. Then when I substitute this x1 into where there is xn, I'll be able to get x2 as 2.2789. Then when I substitute that 2.2789 where there is xn, I'll be able to get 2.2789. So with this, the tolerance is 0 because this minus that is 0. Therefore, that is where I should stop. Now, when I reach the end, I remember the accuracy required in the question. So in the question, they wanted an accuracy of 2 decimal places. So I'll come here, this last value, and round it off to 2 decimal places. So when I do that, I'll be able to come up with my root as 2.28 into 2 decimal places. So basically, that's what they wanted. Now let's see how marks can be awarded. So B1 for getting x0, B1 for getting x1, x2, x3, and stating the root to the required accuracy. So the question required to show existence of the root and use Newton-Raphson's method to find the root corrected to decimal places. So the question was very popular, meaning it appears frequently in the previous past papers. So the weakness of candidates is that the candidates obtained wrong values for location of root as their calculators were not, this word, not converted into radians. So the calculator must first be set to radian mode for you to get the value of f2 and f3. Then also candidates differentiated the variable fx as fxn. I think remember that during the solution I told you, you don't interchange fx with fxn. When you're differentiating, you differentiate fx, and when you're substituting in the expression for Newton-Raphson, that's when you put fxn. Then also another weakness that candidates found initial approximation x0 by performing a dry run of iterations. So this is not okay. You have to look at fx, they will have to look at the extreme values f3 and f2. So f2 is closer to 0, therefore the root must be closer to 2. That's how you get the x0. Then advice to teachers that 1, use radians for numerical values of trigonometrical functions. Then 2, differentiation of fxn, a constant, should not be done as it yields to 0. So always the part when you're going to differentiate, don't put xn. Then iterations are performed by using substitution in Newton-Raphson's formulae and not performing a dry run, which is for flowcharts. So some students were tabulating values of xn plus 1, which is not okay. You have to show physical substitution. So that was question 11. Now we shall go to question 12. So question 12 says a force F, which is given by that newtons, acts on a particle of mass 2 kilograms. The particle is initially at a point 000 and moving with a velocity this meters per second. Determine part A, the magnitude of the acceleration of the particle after 2 seconds. Then part B, the velocity of the particle after 2 seconds. And part C, the displacement of the particle after 2 seconds. So this vector question, you have to first find out where the force is variable or constant. So in this case, if you look at this expression for the force, there is this T and also this T here, meaning that this force is variable because as T changes, the value of F also changes. Now, after realizing that it is variable, what should come in your mind should be integration and differentiation. So let's start with part A, where they want the magnitude of the acceleration of the particle after 2 seconds. So part A, we know that f is equal to ma, therefore a will be equal to f over m. I think realize that here on acceleration I put there the tilde, and also on force I put tilde, but on m I don't put, because m is a scalar quantity while f and a are vector quantities. So when I substitute for f and for m, I'll come up with my acceleration as that, meters per second squared. So the units we are given in the question, meaning that even you have to put the units in your answer. If they are not given, it means that you don't put the units. So you don't WASEC if the units are not given. But they wanted acceleration when t is equal to 2. So what I'm going to do, I'll come and substitute these two here and also here to get the acceleration. First in vector form. Then I remember that they asked for magnitude of acceleration. So I'll come and say that magnitude of acceleration is given by this formula, which gives you 3.6401 meters per second squared. So before I go to the next slide, let's see how much can be awarded for this slide. So B1 for the acceleration function, B1 for acceleration vector, M1 for substitution, and A1 for the output. So that was magnitude of acceleration, but they also wanted velocity of the particle after 2 seconds. So here velocity is got by integrating acceleration, therefore I'll come and say that v is equal to the integral of acceleration, but I already know my acceleration as a function, so it is that. Now I'm going to differentiate that with respect to t. So when I differentiate t, I'll come up with a half t squared. When I differentiate a half, I'll come up with a half t. When I differentiate negative 1.5 t, I'll come up with negative 0.75 t squared. But don't forget the constant of integration, and what you should not forget is that this constant of integration is also a vector, so you don't forget to put this tilde. Therefore, when t is equal to 0, we are told that initially when t is equal to 0, velocity is that. Therefore, I'll come and substitute for t and for v to come up with the constant of integration as 1 to negative 1. After that, I'll substitute that constant of integration into this expression to get my final expression of v. So this plus this will give me this as my final expression of v. So don't forget, units were given the question, so you also have to put the units there. But they ask for the velocity after 2 seconds. So I'll come and say that when t is equal to 2, I'll come and substitute for t here, here, and here to come up with 3 negative 4. So in form of ijk, it will be 3i plus 3j minus 4k. So basically that's what they wanted in part B. Now before we go to the next slide, let's see how marks can be awarded. So M1 for integration, and this constant of integration must be seen. B1 for the velocity function, M1 for substituting the value of t, and A1 for the velocity which they want. Part C, they also ask for displacement after 2 seconds. So shall come and say that displacement is equal to integral of velocity. So I'll come and substitute for velocity function here, and then I integrate it. So when I integrate this, I'll come up with that. Integrate this, I'll come up with this. Integrate this, I'll come up with that. Don't forget the constant of integration in vector form. So next I'll say that initially when t is equal to 0, s is equal to 0, meaning that c is also equal to 0. 0, 0, 0. So I think we realize that we are putting that constant of integration in vector form. Therefore, the final expression for displacement will be this, which gives you that in meters, so the units should not be forgotten. But they wanted the displacement to after 2 seconds, so shall come and say when t is equal to 2, then the displacement will be given by that. So you substitute for t in that expression to come up with 10 over 3i 8.25j and negative 4k, which is that. So basically that's what they wanted. Now let's see how marks can be awarded for this slide. So M1 for integration, B1 for displacement function, M1 for substituting the value of t, and A1 for the output. So the question required to find magnitude of acceleration, velocity, and displacement at time t equal to 2 seconds using calculus, since the force was variable. So when the force is variable, what should come in your mind is integration and differentiation, in other words, calculus. So the question was popular, meaning it appears frequently in the previous past papers. So the weakness of cadence is one, vector symbols and units were not used correctly. So vector symbols must be used correctly. That tilde there is very, very vital. Then integration was not done correctly. So integration, you must be keen when you're integrating. So advice to teachers, emphasize column vector approach. So when you're integrating, it's better to express your vectors in terms of column vectors. Otherwise, if you want to use ijk, it may be more confusing. Then 2, correct integration with a constant to be carried out by the student. So the constant of integration must be shown after integrating as long as the integral is indefinite. So that was question 12. Now we shall go to question 13. Question 13 says, two events A and B are such that probability, so this should be probability of B is equal to 1 over 8, probability of A intersection B is 1 over 10, and probability of B given A is 1 over 3. Determine part A, the probability of A, part B, probability of A union B, probability, and part C, probability of A given B complement. So now we shall start with part A. So part A, we shall say that probability of A intersection B is equal to probability of A multiplied by probability of B given A. So I think we realize that what is here is what we put there. So these two must be the same events. Therefore, probability of A intersection B is 1 over 10, probability of B given A is 1 over 3, therefore probability of A is the only unknown. Therefore, when I make it the subject, it will be 3 over 10. That was part A. Now we shall go to part B. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Then when I substitute for probability of A, probability of B, and probability of A intersection B, I'll come up with 13 over 40. So that was part B. Now we shall go to part C. So part C, we shall say that probability of A given B complement is equal to probability of A intersection B complement over probability of B complement. I think we realize that what is here is what is here. The next is to use contiguous table. You realize that A probability of A intersection B complement is equal to probability of A minus probability of A intersection B complement. Then down, probability of A B complement is the same as 1 minus probability of B. So next is to substitute. So when I substitute, probability of A is that, probability of A intersection B is that, divide by 1 which is there minus probability of B which is that. So when I simplify this, the whole of this bracket will give me 2 over 10 and the whole of this bracket will give me 7 over 8. So when I divide the 2, I'll come up with 8 over 35. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for substitution, this substitution and this substitution, then A1 for the output. Then here M1 for substitution and output. So M1 for this substitution here, and this one for this substitution here, and this for the output. That was part A and B. Now we shall go to part C. So parts we have numerator, denominator, and division. So M1 for this numerator, M1 for this denominator, and M1 for this division. Then B1 for individual outputs, so output of the numerator and output of the denominator. Then this should be A1, so A1 for the required probability. So the question required use of conditional probability, non-mutually exclusive events, and complement law. So the question was very popular, meaning that it appears frequently in the previous past papers. The weakness of candidates is that they consider the events as independent. So when they don't say that the events are independent, they are not independent. The only thing you can use is set theory or contagious table. Then 2 is that they stated wrong probability expressions, especially probability of A union B. Instead of saying minus probability of A intersection B, they are saying plus A intersection B. So advice to teachers to emphasize the difference between independent events in relation to intersection of events. So that was question 13. Now we shall go to question 14. So question 14 part A says, given that y is equal to exponential of x and x is equal to 0.62, correct to 2 decimal places, find the interval within which the exact value of y lies. Then part B, show that the maximum possible relative error in y sine squared x is this, where delta x and delta y are the errors in x and y respectively. Then hence find the percentage error in calculating y sine squared x if y is equal to 5.2 plus or minus 0.05 and x is equal to pi over 6 plus or minus pi over 360. So we shall start with part A. So for part A, we shall say that we are given that y is equal to ex, where x is 0.62. Therefore, the minimum value of y is got by subtracting the error from the value of x to come up with this. So it is advisable, if the decimal places are not specified, so advisable to use 6 decimal places in errors. So minimum value will be 1.849657. Then the maximum value will be got by adding the error to the value of x to come up with, and the end will come up with 1.868246. But remember, they ask for intervals, so it means that we have to put in box bracket, begin by the smaller one or followed by the bigger one. So in other words, the minimum followed by the maximum. So when they ask for interval, you have to write this. This word interval is the same as range, so even if they said range, this is the same expression. However, if they said limit, if the question had wanted limits, it means that they wanted this and this. So you would have said lower limit is equal to, then you write this, then upper limit is equal to, then write that. So the limits, interval, and range, you must be keen of the conclusion. So before we go to the next slide, let's see how much can be awarded for this. So this for minimum value, maximum value, and lastly for stating the interval. So now we shall go to part B, where they wanted you to derive. So first of all, you have to first find out which one is the approximate and which one is the exact. So in this case, the approximate are the lowercase letters, therefore the exact will be the uppercase letters. And remember, the definition of error says that error is equal to exact minus approximate. So we shall say that error is equal to capital Y sine squared capital X minus Y sine squared X. Then after that we shall replace capital X and capital Y with the error and its approximate values. Therefore we shall come and say that error will be equal to, where there is capital Y we put there Y plus small change plus delta Y, and where there is capital X we put there X plus delta X. So after that we need to expand this sine squared X plus delta X, but to expand it you have to use Taylor's method. Therefore we shall have to first make an assumption that this delta X is much smaller than X. Therefore X squared and higher powers are very small and negligible. Now if they are negligible, what does that mean? It means that by Taylor's rule, this function expanded will be equal to fx plus delta x multiplied by f prime x, where this f prime x is the derivative. So you put this plus dash dash dash, meaning that the expansion still continues, but because of this assumption we have to stop at delta x power 1. So next is to substitute, where there is this is this. Now this fx is this, then this delta x is that, then f prime x you have to differentiate sine squared x. When I differentiate sine squared x, I come up with 2 sine x cos x. When I simplify, I'll come up with sine x squared x plus delta x sine 2x, because this is the same as sine 2x. So that means that I can now go back to this expression of my error and substitute for sine squared x plus delta x. So where there is this, I'll put there this, what is in this box bracket, to come up with that expression for error. Then when I open brackets and expand, I realize that, for example, when I multiply y throughout these two, I come up with, for this, y by this will give me y sine squared x, then y by this will give me y delta x sine 2x. Then after that I'll multiply delta y throughout, so y delta y by this will give me delta y sine squared x, and delta y by this will give me delta x delta y sine 2x. Then there's this minus y sine squared x which is there. So after that we shall simplify, realize that this and this can cancel. Therefore you are going to remain with those three terms. So before we go to the next slide, let's see how marks can be awarded for this slide. So the first mark comes from the correct definition of an error. So when interchanging the definition, that will be already off track. So correct definition has to be error is equal to exact minus approximate. The another mark will be on the expansion of sine squared x plus delta x, but the assumption must also be seen. The another B1 will be on expansion of error and simplifying it to get this expression. So next is proceed. We have to eliminate that this one, so we shall say that assuming delta y is also much greater than y. Remember, we already made an assumption that delta x is much smaller than x, and here we're adding another assumption that delta y is also much smaller than y. That means that delta x multiplied by delta y approximates to 0. So take note of this symbol approximates. Most students instead of writing the word approximate, they use the word tends to 0, which is not okay. So the tends to 0 is used in math 1, but when it comes to math 2 we use approximation sign. So when this one tends to 0, it means that we shall be left with error being equal to y multiplied by delta x multiplied by sine 2x plus delta y multiplied by sine squared x. So next is to get the absolute error. Absolute error means that you put these magnitudes on the error. So this is absolute error. The reason why we get absolute error because relative error is equal to absolute error over approximate value. So after getting absolute error, we can be able to get our relative error, which will be equal to absolute error over approximate value. So always take note of that. Most students forget to put these absolute signs. That will be a wrong definition for relative error. So you have to first get absolute error, then you can get relative error. The next is to split the numerator. When I split the numerator, I'll say the whole of this divided by this. What do I get? So what I'll get, realize that y cancels, then this sign squared, one sign goes with this sign, so you remain with cos x over sine x. Then now cos x over sine x the same as cot x, that is why there is this cot x there. Then this 2 is here and this delta x is there. That is for the first term. What about for the second term? Second term, I'll say this divided by that. So when I divide, you realize that this sine squared x cancels with this sine squared x, so I remain with delta y over y, which is that. Now after getting this, I'll have to use triangular inequality. So triangular inequality says that this is less than or equal to when the terms are split. So when the terms are split, I'll come and get the whole of this and put it in its own magnitude, and also this one I put in its own magnitude. So initially the magnitude was enclosing both terms, but after this triangular inequality, the magnitude is for individual terms, this term alone and this term alone. So because of this triangular inequality, we shall come and say that therefore the maximum relative error is equal to this expression. So it is only after this triangular inequality that you can be able to write this word maximum. So previously it was just relative error, but after triangular inequality it becomes maximum error. And when you write this word maximum error, you don't maintain the inequality sign. The inequality sign goes away and you put there an equal sign. So before we go to the next slide, let's see how marks can be awarded for this slide. So B1 for relative error, B1 for relative error, another B1 for triangular inequality, and B1 for the conclusion. So now we shall go to the hence part. So we already know that the maximum error is given by this expression. Therefore, the values of x and delta x which are given, remember the values of delta x was pi over 360 and the value of x was pi over 6. The value of delta y was 0.505 and the value of y was 5.2. So when you substitute those ones, we shall be able to simplify and come up with that. Then when I simplify further, I'll come up with that as my maximum relative error. But the question asks for percentage error, therefore we have to multiply by 100 to come up with our percentage error as 3.9845%. So basically that's what they wanted. Now let's see how marks can be awarded. So B1 for maximum relative error, M1 for multiplication, A1 for output. So the question required to find interval of exponential functions deriving an expression for maximum possible relative error in a function and using it to find percentage error. So the question was popular, meaning it appears frequently in the previous past papers. So the weakness of the candidates were: 1, error was added to on the working value of ex instead of adding it on the power. So most students, what they are doing, they are saying exponential of 0.62 plus, then they first write exponential of 0.62, then they say plus 0.005, which is not okay. So the error must be added on the value of x, not on the whole exponential. Then also stating limits instead of interval. So most students were stating the limits, that upper limit equal to this and lower limit equal to this, but yet instead of interval. So interval, the maximum and minimum value must be put in box brackets. Then next is using differentiation from first principles was a challenge. So there are two methods, one using differentiation, another one using Taylor's rule. So in this video, we learned the method of Taylor's rule, whereby you had to expand the part. Then another challenge is elimination of errors by approximation. So most students were not writing this, so instead they were writing the word tends to. They were using this arrow, which means tends to. So like I said, this arrow is used in math paper 1, but when it comes to math paper 2, always train yourself to use approximation symbol. The introduction of triangular inequality was a challenge, so you have to know that after stating the relative error, the next step is triangular inequality, so that you can be able to get the maximum relative error. So advice to teachers: 1. Adequately illustrate maximization and minimization. Then 2. Apply differentiation when it is a differentiable function. Then 3 is that emphasize correct use of magnitudes and triangular inequality signs. So that was question 14. Now we shall go to question 15. Question 15 says, the diagram below shows a trapezium ABCD. AD is equal to DC is equal to CB and is equal to 1 meter. And AB is equal to 2 meters. So forces of magnitude, this, and that, act in the directions as shown, respectively. So they helped us and they drew for us the diagram. Then part A says, calculate the magnitude of the resultant force and the angle it makes with side AB. Then part B, given that the line of action of the resultant force meets AB at X, find the distance AX. So we shall start with part A. Part A, we have to resolve each individual force into two components, one vertical, another one horizontal. For example, so we shall get negative 60, 5 cos 60, and negative 5 sin 60, 30, 1 cos 60, 1 sin 60, and this. So where do these values come from? Let's see how they come about. So for the first one of 6, you realize that this 6 is entirely horizontal and moving to the and pointing in the direction to the left. So that means that because it's pointing to the left, it is negative, and because it is entirely horizontal, it implies that the vertical component is 0. So that is why here you are saying that the horizontal component is negative 6 and vertical component is 0. Then when you go to the 5 Newton force, this 5 Newton force, horizontally it moves to the right and vertically it moves downwards. What does that mean? It means that horizontally it is positive and vertically it is negative. After finding out the signs, then you have to resolve. So resolving horizontally to now be 5 cos 60 degrees, and it is positive. Then resolving vertically, it will be 5 sin 60 degrees, and it is negative. So that is where this is coming from. The next we shall go to the 3 Newton force. So for the 3 Newton force, it is entirely horizontal and acting in the direction to the right. So to the right means it is positive. And because it is entirely horizontal, it implies that the vertical component is 0. So that is why we have here positive 3, 0. What about for the 1 Newton force? For the 1 Newton force, so from horizontally I'll go this side to the right, which is positive, and vertical I'll move upwards, which is also positive. So after knowing the signs, next is to resolve. So the angle to the horizontal is the whole of this, which is 60. Therefore, horizontal component will be 1 cos 60 and vertical component will be 1 sin 60. So that is where this is coming from. Then lastly, we shall look at the force of 2 root 3. So for 2 root 3, it is moving from this side going this side, so horizontally it is to the right, which is positive, and vertically it is upwards, which is also positive. Now after knowing the signs, next is to resolve. So the angle to the horizontal is 30 degrees, therefore the horizontal component will be 2 root 3 cos 30 degrees, and vertical component will be 2 root 3 sine 30 degrees. So that is where this is coming from. So now that you have resolved all the forces, next is to add and get the output. So when I add, this is that, this is that, this is that, this is that, and this is that. So in the end I'll come up with 3 and negative root 3 newtons. Now this 3 is the horizontal component, this negative root 3 is the vertical component. So when I want to get the magnitude will be 3 squared plus negative root 3 squared, everything under root, to come up with 3.4641 newtons. But I also need to get the direction, so I'll have to first draw that horizontal it is positive, meaning it is acting to the right, then vertical it is negative, meaning it's acting downwards. Therefore, after that I will draw a straight line from start to end, and that will represent my resultant. So when I do that, that will be the resultant force. So this is the right angle triangle, so I'll have to put that symbol, and this theta is the direction they want. So because I know the opposite and the adjacent, I'll use tan theta, therefore direction will be arctan of opposite, which is root 3, over adjacent, which is 3. Now when I use a calculator, I'll come up with 30 degrees as my direction, so therefore the direction will be 30 degrees below AB. So before I go to the next slide, let's see how much can be awarded. So M1 for resolving horizontally, M1 for resolving vertically, and B1 for the output. Then here M1 for substitution here, and A1 for the output. Then B1 for the correct direction. So next they want the distance AX. So the distance AX, first of all, we know that resultant force horizontal component is 3, therefore summation of Fx is 3, and vertical component is negative root 3, therefore summation of Fy is equal to negative root 3. Now next is to take moments, anticlockwise moments about A. When I take anticlockwise moments about A, I'll come up with negative 5 times 2 sine 60 degrees minus 3 times 1 sine 120 degrees. So the question is, where are these values coming from? So let's see where they are coming from. So if I take moments about this point, all forces whose line of action passes through the pivot have 0 moment, therefore the moment of this is 0, so we shall remove it. The moment of this is also 0, so we shall remove it. The moment of this is 0, so we shall remove it because they pass through the pivot. Then we are left with 5 and 3. So let's see how to get those moments of 5 and 3. So the moment of 5, remember we are told that AB from here to here is 2 meters. Therefore, if I want to get the moment of AB, remember moment is going by the formula FD sine theta. So F is the force, D is the distance from the pivot to the force, to where the force touches the line. So in this case, our F is 5 newtons. Then the distance is from A to B, which is 2. Then the angle between the force and this line is 60 degrees. Therefore, I'll say 5 times 2 sine 60 degrees. Then after doing that, I have to ask myself, is the moment clockwise or anti-clockwise? So if you look at this force is taking it in a clockwise direction. Therefore, because the direction is clockwise, remember Anticlockwise has a positive sign and clockwise has a negative sign. What does that mean? It means that the moment for the 5 Newton force will be clockwise and it will have a negative sign. So that explains why when you come here, you'll have negative 5 times 2 sine 60 degrees. Negative is there. Then next we shall see where this negative 3 times 1 sine 120 is coming from. So this force, the force is 3, then the distance is from this pivot up this point where the force is starting from or where the force is ending from. So in this case, since we don't know this distance, we shall use the point where the force is starting from. So from here to here is 1 meter, as we have said. Then the angle between the force and that line is 120 degrees. Therefore, the moment will be 3 times 1 times sine 120 degrees. But after doing that, you have to know the direction of the moment or the sense of the moment. So in this case, when the pivot is here, this force will be in a clockwise direction. Therefore, because it is clockwise, it will have a negative sign. So that explains why we are putting here minus 3 times 1 times sine 120 degrees. So now that we have known that where these values are coming from, next is to use a calculator and get the output. So the output will be negative 6.5 root 3 Newton meter. So I've got G, I have this, and I have this. So when I have those three, I can be able to write my equation of the line of action. So the equation is given by the formula that G minus X summation of Fy plus Y summation of Fx equal to 0. So G is this, then Fy is that, and Fx is that. Therefore, next is to substitute for those three to come up with that one. When I simplify, I'll be able to get my equation as that. But remember, they wanted the distance. So at the point X, where the line of action of the resultant cuts the line AB, Y is equal to 0. In other words, like an X-intercept. Therefore, when I substitute for Y equal to 0 here, I'll remain with only one unknown, which is X. So let's do that. So X is only an unknown. Therefore, when I make X the subject, it will be 6.5 meters. Therefore, I'll conclude that the distance X is equal to 6.5 meters. So basically, that's what they wanted. Now let's see how much can be awarded. So this M1 for taking moments and M1 for the output, M1 for substitution, A1 for the line of action, M1 for substitution, and A1 for the required distance. So the question required to calculate magnitude of resultant force and direction, and also to find moments, line of action, and where it crossed the horizontal side, which is AB of the trapezium. So the question was popular, meaning that it appears frequently in the previous past papers. So the weakness of kindness is that they failed to resolve correctly. They failed to resolve using correct angles in correct quadrants. So those symbols, signs of positive and negative were challenging to many students. Then they also failed to take moments about a suitable point A. So moments must be taken about a suitable point, and that point was A because they wanted distance AX. If they want distance BX, then you take moments about B, but in this case they wanted distance AX, so you had to take moments about A. So advice to teachers to demonstrate angles and quadrants in which forces lie in order to resolve correctly. And also emphasize taking moments correctly about a suitable point. So that was question 15. Now we shall go to question 16. So question 16 says, a biased die with faces labeled 1, 2, 2, 3, 5, and 6 is tossed 45 times. So when you see this number of times, it implies that it is a binomial distribution. And when you see that this number of times is greater than 20, it implies that it is going to be approximation of normal approximation of binomial. So they said calculate the probability that 2 will appear part A more than 18 times and part B exactly 11 times. So the first thing to do is to get the mean and standard deviation, because we have to approximate it to normal. So we know that n is 45, p is the probability of success is 1/3. So why? Because the probability of getting a 2, there are only 2 2's out of the 6 sample space, so it will be 2/6, which is 1/3. Then 2 is the probability of fail, which is 1 minus probability of success, and 2 is 2/3. So now that I have n, p, and 2, I can get mean and standard deviation. So the mean is np, and it will be equal to 15. Then the standard deviation is square root of np2, and it will be equal to root 10. So before I go to the next slide, let's see how much can be awarded for this. So B1 for getting mean and B1 for getting standard deviation. So now that I've got mean and standard deviation, next is to approximate to normal. Therefore, so that let x be the number of times a 2 will appear. Therefore, probability of more than 18 times the same as probability of x greater than 18. So by continuity correction, x greater than 18 is the same one tends to probability of x greater than 18.5. So where is that 18.5 coming from? There is a simple trick which you can use to easily get that 18.5. So what is that trick? One is draw 3 lines. One give it this very value, which is 18, and that should be the middle value. Then the value to the left will be 17. Now remember, binomial is discrete. That is why we are using integers. So yeah, the next will be 19. So after that, go to this inequality. It is greater than 18, meaning that it starts from 19. So say start from 19 and go this side. Now that is binomial, but I want to change it to normal. So by continuity correction, what I'll do, I'll pull this one backwards by 0.5. So when I pull it backwards by 0.5, you realize that the one in between 18 and 19 is 18.5. That is why this 18.5 is there. So that now this is now normal distribution. This was binomial, this is now normal. Remember, binomial we use only integers, but for normal we can use decimal points. Therefore, we shall come and standardize. So standardizing says that this minus mean over standard deviation, and realize that this was x and now this is z. So when the value of z must be rounded off to 3 decimal places. So always remember that after this calculation, the value must be rounded off to 3 decimal places. Then after that, we shall use tables. But before we use tables, we shall first make a sketch of the normal curve. So first of all, that is 0. Then we shall locate this 1.107. Then we shall shade this inequality of z greater than that, and that will be that. So what does that mean? It means that this shaded part is 0.5 minus phi of 1.107. So why? Because the whole of this from here up the end is 0.5, but from here up to here is phi 1.107. Therefore, the remaining part will be 0.5 minus phi of 1.107. Therefore, come and see that from here, this probability is equal to 0.5 minus phi of 1.107. So after writing that, next is to use mathematical tables. So they will always give you mathematical tables in your Uneb examination. So we are looking for a value of 1.107. So this, remember, you have to remember that we are using cumulative normal distribution because there are two tables. One has normal distribution, another one has cumulative normal distribution. So for our case, we ignore the normal distribution table and we take the cumulative normal distribution table. So we want to look for 1.107, so I'll come and say then my 1.1 is here, then 0 is here, so I'll read this value, which is 0.3643, and it is there. Then along this very line where I've got that point from, I'll look for the z value of 7. So 7 is here, so the corresponding value is 15. Therefore, remember, these ones have to be to 4 decimal places, so it becomes 0.0015. So when I add these two, I'll come up with 0.3658. What does that mean? It means that now the probability of phi 1.107 is 0.3658. Therefore, 0.5 minus this probability, I'll come up with 0.1342. So basically that's what they wanted in this part. Now let's see how the marks can be awarded before we go to the next part. So B1 for continuity correction, M1 for standardizing, and this M1 for subtraction here, and this B1 for the table value here, and A1 for the output. So for part B, they wanted exactly 11 times, which is equal to x equal to 11. Now for x equal to 11, it means that it is, by continuity correction, to be plus or minus 0.5. Therefore, it becomes 11 minus 0.5 is 10.5, which is there. Then 11 plus 0.5 is 11.5, which is there. Therefore, this is binomial, and this is now normal distribution. Therefore, next is to standardize. And round off to 3 decimal places. It will become, this will be that, and this will be that. So next is to make a sketch of the normal curve. So this value is negative 1.423, so I'll come and locate it. There's negative this and negative this, so I'll start with negative 1.107, then followed by negative 1.423, which is there. So the region required is this shaded part. Therefore, and that region, by symmetry, it will be the same as that. So this area and this area is the same by symmetry. What does that mean? It means that this shaded part is equal to phi of 1.423 minus phi of 1.107. Therefore, come and state that this probability is equal to phi of 1.423 minus phi of 1.107. So phi of 1.423 will be got from the calculator. So we can be got from the calculator or from mathematical tables. So in this case, we are going to get it from the mathematical tables. The good thing, this was already got in the part A. Now we are going to see where this 4.226 is coming from. So still on your cumulative normal distribution table, you'll come and look for 1.4, which is there, then go and look for 2, which is there, then along the same line look for 3, which is there. Therefore, you are going to add this, which is this and this. Remember, they have to be 4 decimal places, so it will become 0.4226. So that is where this is coming from. Therefore, when I subtract, I'll be able to come up with 0.0568. So in this part, B1 was for continuity correction, M1 was for standardizing, B1 was for this M1 was for this subtraction, and this B1 was for this table value for 1.423, and A1 was for this output. So the question required finding the probability that 2 appears when a die is tossed, using normal approximation to binomial, and also calculating the mean and standard deviation. It also required adding and subtracting of continuity correction. So the question was very popular, meaning that it appears frequently in the previous post papers. So the weakness is that candidates failed to find the probability of success and used few decimal places. Remember that 1 over 3 is 0.33 recurring, so what students did, they would use 0.3 or 0.33, which is not okay. Then to use of binomial, yet n was greater than 20. So whenever n is greater than 20, it has to be approximated. Then add or subtract continuity correction and reading of table values was a challenge to many candidates. And also use a calculator to obtain probabilities was also a challenge. Then advice to teachers: 1, probabilities should be at least 4 decimal places. So when you use tables, that will be 4 decimal places, and when you use a calculator, that has to be 5 decimal places. Then emphasize normal approximation to binomial for n greater than 20. Then illustrate addition and subtraction of continuity correction. I think I've shown you that by using a number line. Then use of tables and calculators to get correct table values. Then use of fractions for recurring probabilities. So the P and Q had recurring decimals, so it is advisable to use fractions. So that brings us to the end of this paper. So a brief summary is that the paper comprised of 2 sections, A and B. Section A had 8 compulsory short answer questions, and section B had 8 extended answer questions, and a candidate answered only 5 questions. The questions were from the topics mechanics, statistics, stroke probability, and numerical methods. So always topics in paper 2 will come from these areas. So mechanics, there will be 3 questions in section A and 3 questions in section B. Statistics, stroke probability, there will be 3 questions in section A, 3 questions in section B, and lastly numerical methods, there will be 2 questions in section A and 2 questions in section B. So the paper was more difficult than that of the previous year. The time of 3 hours allocated for the paper was adequate. So the well done questions, these were the well done questions, and these were the poorly done questions. These were the most attempted questions, and these were the least attempted questions. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on Uneb 2018 of paper 1. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on solutions for Uneb 2018 of math paper 1 has been uploaded. Otherwise, thank you for watching, and also if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.